Welcome everyone. This is the Trainer and AutoML Working Room Community Call on 1st of October. As always, we record this call and publish on YouTube, and we follow the CNCF Code of Conduct. So welcome everyone. So just before we get started, do we have any new people who are on the call who just want to introduce themselves? Just want to say hello.
Yeah, I can introduce. I've been here a long time ago, but I haven't been here for a long time. I'm Vanessa Sockett. I'm a computer scientist at Lawrence Livermore National Laboratory. And I'm here with my colleague Dan, and we're going to be talking about Flux Framework, which is a workload manager. It's analogous to Slurm. It also handles MPI Bootstrap, and we're going to be talking about how we can kind of integrate it as a runtime and a plugin into Kubeflow to enable all the cool MPI machine learning Kubeflow stuff. So it's a pleasure to be back and to be talking with everyone.
Yeah, that's great. Thanks for joining us, and thanks again for all the help with Trainer release before. So it was super helpful discussion we had like last year. So we finally, have something on track. Thank you for this. Yeah, Daniel, go ahead. You want to say something?
Sure. I'm just going to introduce myself. Hi, nice to meet everyone. I'm also a computer scientist at Lawrence Livermore National Laboratory, and I specialize in cloud and HPC converged scheduling and kind of elastic scheduling algorithms.
It's great. Thanks for joining. Yeah, great to have you here. I think that there are a lot of discussion on HPC and how those capabilities can help us to run those workloads. So definitely exciting to talk about it. Um, Anyone else before we get started? Feel free to unmute yourself or use chat if you want to say hi. All right, then again, I guess we can just go quickly through agenda items. So before we jump to the Flux discussion, I just want to maybe quickly talk about the updates and the release for Trainer and SDK. So I think as we announced on the last call, we finally released the first release of Kubeflow SDK, and this is this is great. So I guess the first release including only a trainer, but I see a lot of activity there happening and I see a lot of interest from multiple, like projects and organizations to see how we can streamline data science experience using the Python first interface. Definitely take a look, check these release notes. We're planning to release 0.2 version relatively soon. I think around maybe before KubeCon, maybe sometime in October. So definitely it will be interesting to see how we can, plug in other capabilities to this SDK, like optimizer or optimization jobs, or even like Spark for Spark processing. So pretty exciting for this. For 2.1, so we have this also tracking issue that we're planning to release Kubeflow Trainer 2.1 around mid of October. So at least having the first release candidate. I think there are several features we definitely need to work on and need to help with in terms of review and finalizing the implementation. So if you have time and want to help us, please take a look at those checklist items and feel free to help us with reviewing those PRs, especially because some of them are like almost finished, but some of them needs to be reviewed as well. Right. Any questions for the release, like for the planning here? All right. I think I also want to announce that we recently released Kubeflow Trainer to the 0.1, making the new patch release. So this is like actually very important to like this. We've done this release specifically for integration with KQ. So recently I shared yesterday that we have few contributors who help us to integrate train job workload within KQ. So this is amazing because again, we see more and more organizations using this as a main scheduler or dispatcher. And previously, this had integration with PyTorch jobs or TF jobs, and right now we can orchestrate the train jobs, which is great. Definitely exciting to like see how we can enable topology-aware scheduling, gang scheduling, and other capabilities like file sharing within KQ using train job CRD. So please stay in touch, and definitely more things coming in for this type of integration. All right. Any questions for the release planning, or we can jump to the next discussions?
I can give you some quick feedback that we tested Kubeflow, both the Python API and just kind of deployment in a user space Kubernetes. So that's what you'd run under HPC. In an auto scaling EC2 cluster on AWS, and it was really nice.
That is great. Like, did you use the Python API just to scale the,
So we didn't use the Python API to do any kind of scaling. We used the Python API with just very basic examples. And yeah.
Yeah,
And
that's
then
great. Like,
just a traditional YAML, because we wanted people to kind of see both views of it.
And like, like, did you run just like MPI workloads or Torch workloads? Like, what type of workload was it?
I think we just did very basic like PyTorch.
Okay. Yeah, just Torch
We just
distributed,
needed
right?
something quick and fast. And we also kind of showed them how easy it was to kind of to expose different models, which a lot of things that are very hard on HPC that Kubeflow makes just seamless and easy.
Yeah, that's great. Like, we would love definitely to hear their feedback in terms of experience and what they
Yeah,
expect.
our goals are to have this environment on traditional HPC, so you can have your Kubernetes and Kubeflow and eat it too.
Yep. Yeah, absolutely. Yeah, I think, like the goal of this is to make it easier for them to scale their workloads. And, like if we can provide them a simple APIs interface, I think it's really interesting to investigate. But definitely, especially on the scale side, like I think we probably in some time in the future we might need to do some benchmarks to see, because we migrate into index jobs and job sets, like what are their benefits compared to even like V1 version where they have the PyTorch job and then we run the entire orchestration within our controllers. Because today we just rely on jobs, so it also might give us additional benefits compared to the first version. Yeah, that's great. Anything else? All right, then I guess we can deep dive through this discussion with Flux. So, Vanessa, do you want to share your screen or you want to just talk about it?
I don't, I guess if you want to just open up the issue, I don't particularly I didn't prepare slides or anything. So to give folks a little bit of background, I already started talking about this, but Flux Framework is the workload manager that's been developed at the lab. It's running on the biggest supercomputer on the top 500 list, which is called El Capitan. And it has a lot of really nice features as a workload manager. So it's a graph-based scheduler. It allows for elasticity, I guess, in terms of the scheduler and jobs. Not all of that is fully implemented in production yet, but it's coming. And it's very analogous to Kubernetes in the HPC space because it's made of different components. So for example, we have a scheduler, custom scheduler plugin for Kubernetes that we're able to do because we just take Flux the scheduler and it has, and we plug it into Kubernetes. And so what we're interested in doing is using Flux as a runtime backend in Kubeflow, akin to, I guess, the MPI operator, because Flux is going to add a lot of really nice features that the MPI operator either can support, but not as well, or doesn't have support for explicitly. And so what this proposal outlines are the kind of two scope projects that I think we can do. The first is an MPI bootstrapping plugin. So Flux can bootstrap MPI, and that's a salient point. So if you look at the way that the MPI operator bootstraps MPI, and this is kind of the vanilla way you do it, you'd use an SSH-based bootstrap. And so I think that means that there's support for Intel and OpenMPI. The benefits of adding Flux bootstraps MPI as well. However, it'll support many more flavors or implementations of MPI than just those two. It doesn't use SSH. It uses 0MQ, which we've shown in papers is a more efficient, faster thing to do. And so we can use Flux to bootstrap MPI. That's a very kind of simple case. But what we're really interested in doing is exploring using Flux as a backend akin to a runtime. Is that the correct term is runtime, right? A runtime backend? Yeah. As a runtime backend analogous to the MPI operator to better explore how it can really extend the way that you run AI ML and actually simulation-based jobs in Kubeflow. I think use cases that kind of combine the AI ML with scientific simulation case could be more fully explored if we're able to do that. So what details are folks interested in talking about? My gut my gut feeling in terms of these two things is that I'd like to start with working on the runtime backend, and then to maybe plug in some example workflows and tests and really understand the use cases. But I want to get folks' feedback here.
Mhm. Yeah, I have like a few questions here, but anyone else want to say something? Yeah, I think it's kind of like pretty interesting in terms of the, so I guess like, you're right. We have two ways of, whether we use Flux mini cluster CRD instead of job set to kick off those jobs, or we building the plugin within, within our default runtimes so it can bootstrap. So when you say Flux can bootstrap API and like using ZMQ instead of OpenSSH, um, so today we're creating the secrets and we're injecting those secrets to the API nodes. So those secrets contains, like the certificates so nodes can talk to each other. So what would be the differences in the Flux way? Like, do we need to configure ZMQ connections between those nodes instead of creating, starting the OpenSSH server on the workers? How would that work?
So if you're using the Flux operator, the simple thing it does is it creates a headless service. And then when you
Mm,
configure the cluster, you basically configure it. So it says, okay, these are the node names that are on the headless service that are in my cluster. The
mhm,
level of security that you do depends on the setup. So there's a separate project called Flux Security where basically there's like a curve certificate, and we use Munge, and that can help to kind of sign, for example, the job specifications within the user scope so that it's protected.
mhm.
You don't have to deploy it with that. So, for running on a Kubernetes cluster, me as the user that owns everything, that I probably don't need to deploy that, but it is possible.
Mhm. And in terms of operator, I guess like it requires CRD, right? Which will run, correct? To
Sorry, what was the question?
like, I mean, I'm talking about Flux operator CRD, which basically like reconcile the Flux mini clusters. Is it the correct like assumption there? Because like I'm wondering on the first approach when you say about plugin based, implementation with Flux, uh, because so like inside the API plugin, what we just do, we're just creating the appropriate config
Oh, you're
maps.
wondering like how it comes
Yeah, yeah,
together?
yeah, yeah.
Yeah. So our very first design with the Flux operator was not great. It required that the user like have Flux installed.
Mm-hmm.
This design actually adds Flux on the fly via kind of like a view. And then
Mm-hmm.
it, based on the mini cluster CRD, the custom resource definition that the user provides, it will create the specific configuration files and the resource specification. And then it can either actually be started as a kind of traditional job. So the idea being that you run a command, it runs and it completes, and then it cleans up and goes away, or it's completed and it just stays there. Or you can actually run it in an interactive context, meaning that you can actually shell into what feels like a traditional cluster and then
Mm-hmm.
launch jobs to the Flux queue.
Yeah,
So
yes.
the reason
Mhm.
it's called a mini cluster is because you're basically creating your entire own HPC cluster in
Yeah.
Kubernetes, and it's up to you how you want to use it.
It's kind of like similar to Slinky, I guess, like how it creates a Slurm cluster on Kubernetes, correct?
Um, I think it's a lot simpler than Slinky.
Mm-hmm.
And I think that the way that Slurm is designed, there's a lot of kind of behemoth components,
Mm-hmm.
and that's not the case with Flux.
Mm-hmm. I see. So I guess like the rough idea is to prepare the cluster, and I mean it could be interactive cluster and could be like, or it could be the batch job, right? Which actually I think the bootstrap cluster run the job and then shut it down after the job is complete.
Yeah, yeah, and actually we even have this is a separate project, but we even have Helm charts that will orchestrate like different experiments in
Okay.
your mini cluster. So I can say I want to run the OSU benchmarks. These are going to be pair to pair. These are going to be
Yeah.
across nodes. This is going to be a single node benchmark. I want 5 iterations. I want this design. I want you to do the logs in this particular way, and then I want you to clean up, that sort of thing.
Yeah, so I guess like like the option two, I mean the option one, if we just using the job set still to run those workloads, but using Flux to bootstrap API would be just easier. I think the question would be, I guess, like from your perspective, you're more interesting to, having the Flux mini cluster CRD being inside of runtimes, correct? Uh,
Yeah, I guess I was thinking of, I wasn't presenting them as like one or two. I would
mm,
like to do one and two.
mhm.
The main question I was asking is like, which one is more interesting to work on first?
Yeah, yeah.
The bootstrapping might, another project that I did is I actually took job set and I just very quickly kind of deployed
Mhm,
Flux in it without, without the Flux operator. And that works very well. You can actually install it from like Conda, Conda
mm,
Forge. So
mhm.
that's something we could test. But I think to get a lot of the, uh, I mean, yeah, I want to do both. I think they're both possible.
Yeah, yeah, yeah.
Yeah.
Yeah, I just think that the first easier than second because then we don't need to because in the second require for us to change an API on a template side. So today cluster, I mean, yes, like when we designed this extension framework, as we discussed before, we have a capability to register your own runtimes, which is not job set based. We just haven't got chance to implement these integrations within our registry. But eventually, like
Okay.
we should have a way to register other runtimes, not cluster training runtimes.
So you're
Um,
saying that the extension API isn't actually complete yet?
yeah, yeah. So yeah, that's correct. So
Okay.
let me maybe show you quickly this. I think we have this documentation in the website. Um, yeah, this is the page you recently created. So yeah, I think the goal is for runtime to, have the cluster training runtime, and any type of runtime that you want to have, which is not job set based. And I think the goal is of this extension framework is to allow you to register dynamically those runtimes. It is not just there yet. Um, I don't think it's hard to, like if we want to support Flux upstream, we can, just add this in our registry, in our controller, and I don't think it's a big deal, to be honest. And we can just make this as an extension. If users want to install operator with other type of runtimes, like Flux runtimes, we can allow them to do so. Um, this is just kind of like require more work compared to just adding the plugin in the first version.
So just
Um,
so I understand, if Flux uses an index job, but
okay.
if the Flux operator used
Yeah.
job set, then it wouldn't need to be like another extension. It could be more a core part because it would easily fit into the current abstraction of job set. Is that correct or?
Yes. Yeah. So I guess like yeah. So when you say Flux using job set, it just directly, I mean, does it have any image to bootstrap MPI or how it works? Like you talk about like a zero MQ channels, right? It's been set up in
So
the
with whether it's a job or a job set, it works the
mm,
same way.
mm,
It starts with a user application container that doesn't need to have, it only needs to have the application in it. And of course, the application needs to be built with MPI. So if you
mm,
do like LDD on the binary of the application, you'll see a path to like libmpi.so. That's kind of a hard requirement. And that's the same case for the MPI operator or whatnot. But whether it's a job set or whether it's an index job, what we do is we have an init container that
okay.
that adds Flux on the fly, and then it works.
Okay, yeah, makes sense. Yeah, this definitely we can add on runs on the on the job set template directly instead of in our templates here we can add this init container which will bootstrap Flux. Um, yeah, maybe it's a good first step, right? Because I guess you want to do both for long term and just to evaluate them, and if we want to show some sort of immediate value, maybe compare them with the raw bootstrapping of MPI. I think that will be super helpful because then we can actually have on the one hand side raw MPI with our OpenSSH server bootstrap plus host files, and then on the other hand side we have the Flux bootstrap. Just maybe also another quick question. So in terms of, I remember previously we talked about PMI-X. It has some problems on Kubernetes. Do we know if this is possible to do with Flux? To
Yes,
boot?
it is.
Mm,
PMIX, PMI2,
mm,
little magic flag that in many cloud environments we've added it and all of
yeah.
our MPI errors have gone away. Yeah, Flux supports that.
Yeah, I think
That's
that's pretty cool. Mhm. And how does it support PMI-X on Kubernetes then?
the same way it supports PMIX outside of Kubernetes.
Mm,
It uses, let's see, on the back end, there's Flux PMIX, and then usually the application, or sorry, that's built with Open Purdy. Dan, how do you say that?
PRT, yeah. It has limited support, so it does not implement all of PMIX because that is a colossal standard. There are specific things that it implements as a shim layer. So there's a special project that you have to build and integrate into. It's like a separate Flux project that you have to integrate in, but it supports some of the features of PMIX.
Yeah, but just to be clear, that is built into our views that we use. So it's usually just a case that you add one little flag and it works.
Yeah, I think this is pretty cool. Yeah, because like I remember we discussed this with Yuki before, an API operator cannot really bootstrap PMX flavor of API. And yeah, it has some limitations there. Um,
Okay, so I understand. It sounds like there'd be interest to get the Flux operator working with job set, and then to also, and so to test that, to test a kind of simpler, like the most bare bones way that we can use Flux to bootstrap something, and then test that against the MPI operator, do a little study that actually compares the three in terms of performance, but also in terms of like what is supported versus what is not supported for features.
yeah, and the
And
question, yeah, good.
and in terms of, in terms of implementation, I can do all the implementation, and we can basically just have, we don't have to like merge anything into the project, right? We can have these in PR branches, and then we can test the PR branches, and then we can come back after these experiments and have a discussion about like which are the best, which are worth kind of getting more hardened into the project, that sort
Yeah.
of thing.
Yeah, I think so. So yeah, using job site as the kind of main foundation orchestration is the one thing, and using Flux mini cluster as the second foundation, as a second orchestration layer is maybe can be another way to do those things, right? Because again, like we have an ability to extend the, add additional runtimes, which are not job site based, but we also, like as you mentioned, we have an ability to add additional plugins, so to our extension framework, which basically instead of API plugin, which using raw API operator like Bootstrap, we can have a Flux-based bootstrap, which add the init container and always require environment variables, which is needed for to bootstrap API with Flux that we've been talking about.
Yeah, just to clarify though, when you place the dependency on job set, are you saying that there shouldn't be an additional operator installed that is orchestrating the job set, or
Yeah,
something else?
so yeah, operator is required. So operator is required because when we, when this basically this pipeline, this flow is being constructed, we kind of like are then constructing the job set. And job set, and maybe we also construct additional resources like, for example, config map for MPI. So we need config map and we need the secrets for OpenSSH. So this is happening on the component builder phase. So basically, like
Right.
when we're designing this extension framework, it has several stages. So it has like the pod group policy stage, the ML policy, and component builder. So in the component builder stage, you can build any Kubernetes resources as you need. It could be even like, Flux CRDs, specific CRDs. Also, it could be, services, config maps, any, Kubernetes resources. And then at the end, like, on post-execution phase, we have the some suspension condition. But basically, our controller creates all those resources together with the job set. So for,
Right.
yeah,
So for example, for the MPI operator,
yeah.
is that using a job set right now?
Yeah, exactly. Like we don't even
Okay.
use NPI operator at all. Like we don't even need to install NPI operator to the cluster to run.
Okay, so is that implemented as one of these extensions, or is it a
Yeah.
core part of the project?
Yes, it's a part of the plugin. So it's a part of this MPI plugin. So in the MPI plugin, we have all of the required environment being set in enforcement. So basically, first of all, so as I said to this picture, we do first of all do enforcement. So enforcement, basically, we add all of the required capabilities to the required parameters to the job set. It's happening on this stage. And here, in the code, we're basically adding the some parameters to the trainer, etc., and some environment variables, some volumes, adjusting the volumes. And we also have the stage where we build all the components required for MPI, like a config map, secrets, and then we
Yeah,
deploy.
it's basically acting as an operator,
Yeah,
called a
exactly.
plugin inside of a controller. Yeah, so
Yeah, yeah,
I can basically take this design
yeah,
and just turn it into Flux.
yeah,
And
exactly.
and
Yep.
do whatever is needed that doesn't require, for example, installing explicitly the Flux operator.
Yep.
Because it at the end of the day, it does come down to like, init containers, config maps.
Yep.
I can, and that would ensure that the same mapping of someone's job that they write for Kubeflow, and when they select Flux, for example, can
Yep.
go into the abstraction.
Yeah,
So
definitely. Yeah, definitely take a look on this and let us know if you have any follow-up questions. But I think this framework allows to, make it extensible. And, this multiple phases allows us to, add additional orchestration for Flux specifically. I think the only question we should answer whether we need another API change, like, Flux ML policy, because then we need to some sort of maybe activate this plugin based on this ML policy. And I'm talking about, the cluster training runtime API.
I
Because
guess
the
I'm a
plugin,
little
yeah,
confused. So the MPI operator, for example, which isn't the MPI operator, it's like
yeah,
the MPI operator implemented in Kubeflow. That is called a runtime plugin, correct?
correct. Yes, some of the capabilities of MPI operator is inside this MPI plugin.
And
Correct.
is
So
this picture that you're showing me, is that the MPI plugin or is that the extension framework? Because we've been talking about both of them.
yeah. So Kubeflow Trainer, right? It has like this extension framework in place, and we have like a lot of different plugins, like a Torch plugin, the JAX plugin, a cost scaling plugin, and another plugin called MPI plugin. And API
Okay, so
plugin,
those are extensions.
yeah. Those are
Okay,
extensions.
gotcha. Because you said earlier that the extension framework wasn't ready yet or something.
No. So
And
I register like dynamic registration is not ready yet. So
okay.
the goal of us like basically to allow users of Trainer to add their own plugins dynamically. Like maybe they have their own in-house framework they want to orchestrate, and we want to give them a way to dynamically plug in. Similar to if you're aware of schedule plugins, you can add your own capabilities there. So the goal here is the same. I give you ability to add another plugins on top. Um, and I'll also add
Okay.
another runtimes, as I said here, on top of this default cluster training runtime to make it extensible.
Okay,
Yeah,
I think I understand and I know what I would do for development.
all right.
As kind of a cool side note, and we talked about this a little bit in the issue, probably after this initial stage of work and we're
Mhm.
more familiar with the code base, it would be interesting to actually talk about the scheduling components because that's another thing that Flex can assist with. But we
Yeah,
don't need to talk
absolutely.
about that today. We've gone way over 15 minutes. I
Yeah,
apologize for
no
that.
worries. Like any other questions, maybe like Anthony, what do you think from your side? Like, does it make sense to you in terms of, how we can iterate here?
Hold on, I was trying to find the button for a meeting myself. No, that sounds good. Like that sounds promising, and yeah, the next action to me like makes perfect sense.
Yeah.
Looking,
Mhm.
yeah, no, looking forward to see it like the in action, like
Definitely. I
yeah,
think identifying all of these things why it is important. Like, we're talking about PMIX, we also talk about performance boost compared to OpenSSH. I think this also would be nice for us to benchmark.
yeah, I agree. And do you think that this dynamic plugin registration would be a priority, or would be like a must-have somewhat, like to at some point have that feature full-fledged?
Yeah, this is definitely what UK has in mind and what we've been
Yeah,
thinking about initially. Yeah, we just never get a chance to,
yeah.
but eventually we should allow customers and end users to add their own plugins on top. So that is super useful.
Yeah.
Um, all right, I think it was super helpful. Again, like I think it's the next step. Like feel free to let us know, like Vanessa and Daniel, if you have any questions. We can definitely, work together in terms of adding this plugin and then adding maybe the runtime based on Flux Mini Cluster CRD.
Definitely. To
So
set your expectation, I have a big bucket of credits that are expiring on a cloud at the end of this month that I probably will be working on for the next couple of weeks, but I would anticipate starting this near Halloween, or at
yeah.
least, and my first kind of steps will be opening PRs and I will post on the issue or discussion if I have any questions.
I actually do have a question, going back to the MPI operator and the use cases. What are the scale needs for the use cases that you have currently?
Yes, it really depends on like what kind of jobs you run. So you're talking about, ML training jobs or fine-tuning jobs. It could be, it depends on your cluster size.
Sure.
But I think from the HPC world, there will be not kind of a very large scale because usually you have limited number of GPUs. I think the problem I think Yuki was mentioning about it, that sometimes a lot of frameworks still using Nickel for
Mm-hmm.
like collective communication operations,
Sure.
but using API to just bootstrap the jobs, which means like we won't get really a lot of performance compared to using Flux, using just raw API operator. But if you talk about frameworks which depends on API for collective communication, I was mentioning
Mm-hmm.
about it's like MLX, for example. I think there we might have some differences. But the scale, again, it really depends on what type of jobs you run. Like, could be hundreds of GPUs or hundreds of nodes. Uh,
Okay. Would
or
you say it would extend to thousands or tens of thousands?
yeah, I mean, like, I think it's really I mean, for pre-training, probably yes.
Okay.
I think but for pre-training, I don't think we are on this stage. I mean, we don't really. I know there are some very large scale jobs have been run with using JAX, using TPUs, like GK TPUs, but I don't really know about any use cases using job set with GPUs in terms of large scale. I think some of those benchmarks probably maybe we should ask some job set maintainers, but speaking about hundreds or thousands, definitely would be reasonable. But we need this amount of GPUs, right, to test because
For
you,
sure, for sure. That would be the limitation, I'd
yeah,
imagine.
yeah, yeah,
And
exactly.
and typically in these deployment scenarios, are you deploying or instantiating one MPI rank per GPU or one MPI rank per VM, or
Yeah, I think
depends?
it really depends on topology. Like some
Okay.
of those nodes might have multiple GPUs within the single node.
Mm-hmm.
Which means like like basically have multiple slots. So in the API world, every GPU is a slot. And when you have a one, like basically you can define number of slots and number of processes. And when you have multiple GPUs within the single node, it multiple slots within the API context.
Mm-hmm.
So then I guess we can imagine there will be more than one rank for one. Does that make sense,
Yes.
Daniel?
Yes, it does. Yep.
Yeah.
That's what we're familiar with. Mm-hmm.
Yeah. So I think like definitely lower compared to number of ranks compared to CPUs, because CPUs you have much more compute to run, but because you're still limited within GPU context on the API side. But yeah, all right, should we move on? Sounds great. Thanks for the great discussion. Looking forward definitely for our benchmarks and see how we can enable this within trainer and train jobs. So really exciting for this. So I think we have two topics to talk about. I know I want to talk about optimize, this new API for HPO, and I think we also want to give a little bit of updates for data cache from Akshay and Akash. So what first we want to talk about? Any suggestions? So actually, since it doesn't require a lot of time for you to give an update, maybe you can quickly share maybe give update what's happening on the cache side. And
Yeah. Um, can you hear me?
yep.
Hey, everyone, this is Akshay. So I think on the cache side, we are almost there. We've merged one of the actual implementation of cache. So I'm working on the areas of Kubeflow trainer integration. So a couple of PRs are already out. So if you can help review, that will be helpful. And so my next steps are to actually try to build examples to publish so that users can play around with cache. So these are the main things, and hopefully we'll be ready by the release, which will be releasing this month. So we should be ready by then.
Yeah, I think that sounds great. Like, I guess like we're targeting this release to 2.1 to release first version of data cache. Things we built for using Apache Arrow and Apache Data Fusion. And that I think there are changes required for SDK, as I actually mentioned, for initializer we need to release. Any maybe questions for this? Like any follow-up discussions you want to have?
Yeah, I think one other thing, probably after the release, I think we want to there are many to-do items in the cache and also on the initializer side. So I think we need to refactor, and we also need to add certain features to the cache. So probably I'll set up a follow-up issues on the cache side.
Yep. And for those who like want to see how this cache has been bootstrapped, so we have this, this small README to explain how you can build this and run this locally. And I think we already have a few folks who are trying to run this locally. So please take a look. I think like one thing we definitely need to talk about how to test it on the raw data and how we can put some data in Parquet.
Yeah. So that's one of the exactly. So there's one of the action item on the example side, and also on the CI side, to how to make sure that we have regression testing for cache and also its integration. So that's something which I'll work on.
Yep. One of the things that but definitely needs to maybe you can take a look actually like before the release is this dependable PRs to update some versions in Rust packages. So
Sure.
if those are
Yeah.
low risk, definitely you just LGTM, then we can merge them to the upstream.
Perfect. Yeah.
All right. Any other questions for this? Sounds great. So for this pod template overrides, do we know who is adding this? Like, I know there's still some work we need to finish here to add labels and annotations to the pod template overrides. Any discussions, Anton, you want to have here, or I think we're ready to go with this PR?
Yeah, I think we somewhat reach a consensus on what we. It was, I think, Yuki that he had maybe an open point that was about using, the Kubernetes metadata struct directly, and other people were, and even I was maybe suggesting we could go conservative and only be explicit about the field that can be overridden, like labels and annotation.
Yep. Yeah, I think it looks good. I think like if you all agree with this new pod template overrides API, that definitely will make sense. I think we should discuss at some point like what will be API deprecation for next version. So that definitely let's talk about it after 2.1, because then I guess we need to deprecate pod spec overrides towards pod template overrides.
Yes.
Sounds good. Okay, so for this, Akash, do you want to share like your updates for command model quickly?
Yeah, sure. So, I mean, a quick update from my side. I think last week we wanted to do, but yeah. So we added example for Gwen 2.5 model to the trainer repo. I mean, for now, again, add example was another thing, and we are using that example to run our GPU E2 test. So that's there. For now, like plan is to use that because I think the previous model, Llama model, which you were using, those were requiring Hugging Face token. So that was not actually very scalable for at least for PRs and other things. So after example, I'm working on also supporting ARC controller where we have a scalable model which support GPU E2 test. And for now, we are running like single example, which is basically the Gwen 2.5 runtime example model. So yeah, that's about the at least the added PR, and again the future scope of this ARC controller.
Yeah, this is great. Thanks for this. Wondering if you want to add more runtimes to the upstream support eventually, because we have Quen, we have Llama. I know that we doing some work to move to other frameworks, not Torchstone based. But wondering if any users want to give any additional value if we add more runtimes to the upstream from Torchstone.
No, I think there are from Microsoft there are 5 models and there are one other models. Maybe we can add that as well. Only issues like those we cannot use for our E2 test because those require a Hugging Face token. So I think I remember 5 model is there. There is yeah, I think here you can see recipe. Can you do recipes? I think yeah.
Yeah, we're gonna add Phi or I think
Yeah.
Mistral. Yeah, Gemma
Yeah.
as well from Google
Gemini
Cloud.
is there. Yeah. Few of them do require token, but at least for runtime and for example, we can have those as well. So maybe in future down the line, we'll see if we can add more example, at least one of a common family. For example, Gemma 1, 5 1, something like that.
Yep. Yep, that sounds good. I think like, as I hope, and I think I talked about it 2 weeks ago, that we need to find a way how we can quickly allow users to fine-tune those new models on Kubernetes. So because basically, when new model get released, we quickly have a runtime. We may even make a release, and then we tell users, hey, right now you can fine-tune, GPT OSS on Kubernetes using this simple API. So I think this is something we need to be going towards to, similar to VLLM, like how VLLM announcing support for new models.
Yeah.
So I hope we can do something similar here for the long run.
Yeah. Yeah, of course. Sure.
All right. Anything else? Any questions for this topic, like how we build, how we're managing the blueprints for those LLMs? All right. Then I guess maybe let's talk about this KDP SDK migration that we recently started. The project is about. Um, so I think just to give a short heads up here, we try to merge more capabilities to the Kubeflow SDK, and we try to allow give customers capability to use Kubeflow SDK with HPO jobs, high parameter optimization jobs. And today, there is no way um, to do it because you have to install KDP SDK separately, and KDP SDK doesn't really so it has a different API design. So we try to see how we can give users some sort of short to the medium term value of integrating the KDP capabilities to the Kubeflow SDK. I think the long-term vision here is to refactor KDP CRD to something else, but that will take time. Like refactor basically experiment CRD to something which is specific to HPO. So we don't really confuse our users when they talk about experiments. And this is actually proposal is about what should be our first step to at least give users the short-term value of this new API. Annie, do you want to give any context for this before I jump to this initial API design?
Context for what?
Like basically the context of this proposal and what we try to do.
Yeah, sure. So we are looking at the migration of KTP SDK to the unified SDK. Right now is the next SDK. So we have previously migrated trainer SDK. So the approach of migration should be pretty similar. So I'm currently working on the separation of API models from the SDK directory. And then we'll publish those to PyPy imported from Kubeflow Unified SDK. But currently we are looking at the optimizer client API so that it can work well with trainer v2. Yeah, to provide like a seamless experience for data scientists who want to optimize their train jobs. So we're looking, there are like 3 options right now at the moment. Yeah, the first one we have
Oh yeah.
covered
Yep.
yesterday. So if you want to go ahead.
Yeah. Actually, you have your hands up. Do you want to first of all, before we jump to
Okay.
options, ask your question?
Yeah, I just have a question on the migration, specifically on the initializer. So, are you so basically, the idea is to use trainer v2 if I not if I remember correctly, and
Yeah.
I just want to understand what is the roadmap for initializer. So, how are we trying to initialize
Yeah, I was actually
specifically?
Yeah, I was thinking about it for quite some time. I think we definitely have few options how we can initialize assets before HPO jobs bootstrapped. And I think the main difference is that, when you run multiple train jobs within optimization jobs, you only need to initialize your asset once, and then you can reuse the same initialization for all those train jobs. I still kind of want to use capability of initializer within trainer, but find a way how we can maybe bootstrap it only for the first trial, and all other trials will reuse the same assets. I think the
I see.
trick would be the trick would be there, like what should be the API design for this.
But still the initializer would be invoked from individual train jobs, right? In this case.
Yeah, like one of the option, and I think it's maybe kind of tricky, is to only invoke initializer for the first trial, and all other
Okay,
trials won't have initializer job. They just share the PVC or getting the data from the cache. But I
got it.
don't know if this is
And
the deal. Yeah, good.
just a question on the, so the is a trial map to multiple train jobs?
Yeah, exactly. So I think we have the diagram here. So this is the KDIP architecture. So when we spin up a trial spin up multiple jobs. It could be, in the KDIP it has can be PyTorch jobs, Arc workflow, but we talk about only train jobs. And
Got it.
every trial is actually representing the one train job.
Makes sense. And the trial controller is the one which we already have under Katib, or
Yeah,
is
yeah,
something new which
yes.
we are.
Yeah, today KDIP has three controllers, like experiment, trial, suggestion, and trial controller responsible to spawn these trials and orchestrate them.
Got it. Just want to see whether we have an API that would be separate, similar API like initializer, but can be reused from directly with trials that
Mhm.
would simplify asset downloads, not just for like datasets for models too, right?
Yeah, exactly. So again, like as I said, like we could do a hack, and I don't know if this is the good thing, and because like we can only spawn the first trial with an initializer, and all other trials don't have initializer. We only do initializing on the first step, on the first train job. All other train job just reusing the same basically PVC or the same cache that we bootstrap as a first train job. Um, Alternatively, we have to do this orchestration within trial
Mhm.
controller somewhere, correct?
Yes, I think, yeah, that makes sense. I think having it in a trial controller would simplify. I'm not sure how what's the effort there
Hmm.
instead of hacking basically.
Yeah, I think the trick is for us because we try to reuse as much context from China as we can. Like
Mhm.
basically, we try to use exactly the same API in the trial template. We might need to have a runtime which has initializer there. Otherwise, we need to find a way. So yeah, so maybe actually, like if you can help us to maybe propose some ideas on how
Mhm.
this
Sure.
initializer can be managed, I think will be
Yeah.
helpful. Yeah, maybe like to make a note
Yeah,
here.
basically it will be useful for cache as well, because one of the idea for cache too is to have to optimize the data loading side.
Yep.
So probably it would be good on the bootstrapping cache as well.
Yep, that makes sense. I think like the overall question is that that should the initializer always exist in runtime when users want to use them? Because today I think like in the controller, like if your runtime doesn't have initializer, you cannot really add initializer with your API. So we need to find a way to figure out it.
Makes sense.
All right. So for the options, I do want to go ahead for the options, or I can give a short overview for this proposed design first.
Yep. You go ahead.
Yeah, so
Charlie.
just maybe quickly. So I think like we tried to find again, as Anya mentioned, a couple of new names for this HPO type of tasks. So I think there are, if we try to make it, so some of the frameworks using different names. So we know like Sweeper client is one of the names that Weight and Biases is using. Static client is something we've been using before. And I think the Optuna project also using static client. Optimizer client maybe gives us a lot of options because you can literally optimize not only HPO but any type of workload. It could be inference workload, could be data processing workload. So it gives you more opportunity of what you can in the future extend with this name, but open to any suggestions here. And for the API design, I think we have like actually four main primitives, like four main things you should define for your hyperparameter tuning jobs. So the first thing, an objective, like what you want to optimize, like it's basically what are the metrics, what is the direction, what is the goal, your final goal, what algorithm like you want to use. It could be random search, grid search, Bayesian optimization. And then you should define a child policy and a child template. So child policy defines like how many trials you run in parallel, how many restarts you can tolerate, what is the deadline for your trials, and the template is actually the template for the trial. And we try to add the search space directly to the trial template, so users can do something like, they want to optimize learning rate or they want to optimize number of epochs, they can directly define it here. Yeah, so and again, like the simple version of this could be something like this. So you basically define just your trial template and your algorithm, your objective. And similar to this, we can also do the same with the built-in trainers. So in a built-in trainer, like instead of me defining the function, I can just say I want to optimize my LoRa config or other configurations here. Maybe any questions or suggestions, like is this design make sense or we want to change something here?
I have added two alternatives under those. Yeah, so the first one is that what I mentioned yesterday, instead of like providing those configs, like I don't have a strong opinion of any of those, but just to show the alternatives, this one is similar to what Optuna does. We just provide the direct arguments to the optimize API and that's it. So I'm not sure if those like trial template, trial policy configs might be confusing to data scientists. So maybe that could be simpler or not. And then the search option is similar to probably somewhere like RayTune and then the first year option. So yeah, the optimize config is something like the objective. And then also the execution config is like a trial policy, but to me, like the naming seems to be easier to understand.
Yeah, if the child policy is definitely confusing, we can find a better name. I think the only kind of trick I see here in the future, we can support more objectives. Like Aptuna, I think Aptuna already support multi-objective optimization. So we should definitely think about the long-term idea of, whether we want to optimize more metrics in terms of single run, optimization job. So definitely that should be array. That is why I try to separate objective from the optimization config. Yeah, I kind of like, yeah, the question, like if we have to optimize here, it might be, I would say, less explicit because then, we have optimize parameter under optimize API, which might be slightly confusing, or otherwise we should change this API to something else.
I have feelings like optimize config is understandable. You just configure the optimize API.
Yeah.
But yeah.
I think it's like how we, because, like I think I also mentioned a little bit about early stopping. So like this idea gives us more opportunity to extend the policy or execution config to something else in the future. So I think as I mentioned here, like adding scheduler, like medium stopping scheduler or something else. And like just to give you a context, like why I added template, because the custom trainer specifically a train job, but what if we want to support non-train job type of optimization? Like it could be maybe in the inference service, or it could be Spark jobs. And then we can even add the Spark jobs as part of the template idea in the future. So yes, I'll go ahead.
Just like at the end of your document, I scrambled it with some suggestion that I have in mind, which is suggesting to use something like a builder design pattern. Since we have a lot of arguments that like the optimization job looks very big, forget about this builder. If you go at the bottom of this Python code, so it's like the train job would be like, okay, optimization builder. If we use the optimization or optimizer as like kind of builder, so the Python kind of annotation doesn't really work here because it's a suggestion. Then here you would just create a builder and say, okay, I would like to set this, I'd like to set that, and it can be nested. Like it can be dot with random search, dot with set trial, dot this, dot that. So this one could be like a little bit cleaner, and at the end you can just like hit run. That will make things a little bit easier for people, and things that must be set. I think that the run will kind of code another function implicitly, like validate or something. to validate all your parameters are set for the optimization trial. And then if everything is in place, it works. If not, it would just like fail. The builder, just to make it easy for the user to see what's happening, and instead of like passing all the parameters to the Pythonic interface, looks a bit complicated, but that's a suggestion. If we don't like it, we can reject it.
So just a quick question, that is it something that, for example, we can support two options in the new API, that like we can also provide optional in the builder, right? And user can choose whatever option.
Yeah. Yes, I think like the underlying API could still be there, and that's like what the builder is probably going to use. So the builder itself will create like the trainer client, will create like sets and runtime. I probably pasted the code and explained to an LLM to what I want, and I would like to use a builder design pattern instead of me writing the code. So that's a generic code. So I'm not familiar with 100% of what it says, but I use like Gemini to kind of to do that, like the builder implementation for me, because like I just got this idea right now. But we can keep the like the higher level API, which is like the client, anything else, like the trial, everything we have, we can keep it as it is. But we also add a builder, which would allow users to kind of use the builder directly to build it in a nice way.
Yeah, that's something that I've been thinking about when you've been developing the local execution mode, like creating the builder optionally to make it easier. But yeah, I mean, that's something we can provide optionally, right?
Yeah, definitely. We can make it as like, okay, use the optimization. Well, use the X builder. I'm just using X here because we didn't pick a name yet, and I don't want to dictate a name. So use X builder, and if X builder is easier for you, go ahead. If you would like to use the underlying API directly, your call. So if you want, you can accept this one as an option, Andre and Anya, and we can discuss it.
Yeah, definitely. I think like, the goal of, and I know we were time, sorry, like we keep you late, but like I think like builder is an interesting idea, similar to how we discussed the options on the, I guess, the options for trainer
Yeah.
SDK.
For the SDK.
Yeah. I think like, I just try to, again, I think as I mentioned on the yesterday call, I try to make it as easier as possible for users to, migrate from from trainer client to optimizer client. And like if you make those APIs very consistent and easy to understand, maybe it would make it easier for users to, work with them and you start to play with them. And if something is really confusing here, and I can add this simple example here to see how the migration will look like, then we can see, what should be improved and what should be modified. Because if the builder, I guess, like, if we decide to have a builder, maybe we should have a builder for trainer as well, right? Because today we have the clients, the train API that you should invoke.
Yeah, it's a little bit different for the trainer, to be honest, because like the trainer is it's a single function, which is train, we mainly call. If you know which runtime, I would assume the user would know like what runtimes he has, and never call like the list runtime API, and then it was like, here is my train function straight away. I don't need any other function. There is not much parameters we provide. We just provide like the trainer, initializer, and that's it. But if we want, we can add the builders as like something on top. If people would like to use it, could be helpful.
Understand.
But no strong opinions still. Like if we would like to ditch it and just keep the old API, I think the old API will still there anyway. We're not going to delete it. We'll just like add something to simplify how you could deal with this.
So do we see that this is kind of complex for this? I guess like the complex, but like the confusion part is the trial policy, right? I think as Ioanni mentioned.
Yeah, and then trial template.
See.
Yeah, I don't know. Like, I mean, what do you think about other options? Do you have any preferences in anyone on the call?
Yeah, maybe
I think the builder pattern is, I think the builder pattern seems to be nice because it simplifies writing code basically. You don't need to, if you go to the other option where we have types, so you need to conform to the types. You need to know the trial template. Probably it's more Kubernetes way of doing things, right?
Mm-hmm.
But the builder is more like a SDK style.
Mm-hmm.
Yeah, I think I think like Seb mentioned, probably we can have both.
Yeah, and maybe, you know, like we can, yeah. Yeah, the question is like, you know, whether this builder will be required for you to say. I guess the trial is confusing part, right? These two part is confusing for scientists, might be.
Exactly.
But
Yeah,
it,
they would need to know about the built-in primer or the template, the structure of the template itself, right?
Not really, because trial, I mean, trainer is just part of the trial template, right? It could trial, you know, trainer could be,
Yeah.
we can have one off. It could be trainer, could be Spark job, it could be, you know, in futures inference or something we can talk about.
Yeah, but either way, user needs to know that the template has trainer and it's not the other way or something else.
Hmm.
I mean, at least user should be aware of the structure of template in this case.
Yes, I'll go ahead.
I'm sorry for dragging you guys and speaking at the last minute and just dragging this conversation. But I think also we should maybe like rename the trial template, and that be like trial template will still exist, but maybe we can create like something different, like a trainer trial template, and there could be like different trial templates that we in the end it will be compiled to something that we pass to Katib, and Katib will take care of like executing this. But we could like have a base trial template, which is like the parameters that you need to pass, or every trial template will have like it's like an interface. So the trial template, what we care about is like a function on the trial template that's called like, for example, get template or compile template or whatever, and then this will compile to something that Katib expects, and we pass that to Katib, and that's it. So for trainer, we have a trainer trial template, and we can extend this to support other stuff. Like, so we can add, I don't know, I'll just make up something, MPI trial template, because MPI was mentioned so much on this call. So that's not a thing. It's just like an imaginary example, and then that compiles. We will keep the trial template itself, but it could be like more generic. It's not trainer special kind of thing. You know what I mean? So it could be like generic one.
Yeah. So that, and then like we can have a one-off for the template you can specify here, or
Exactly. As long as it's a fork, or like it's a child of the base template, then the function, the optimized function, will accept it and will just like compile it into something that Katib will process.
That also makes sense. Yeah, let's definitely continue this. Like, I think like those ideas interesting. Like, I think the question is like what we should do. I probably also need to spend time to also give you the experiment YAML, how it looks like, and maybe in the future how the optimization job API might also looks like in the future. So that will at least give you idea how this actually get translated to the KDIP job, at least initially. So that is why that is probably will give you idea why I'm using template here and why I decided to use policy here. But yes, if we, you know, make it more specific to trainer, I think it maybe makes sense instead of having this as an interface defined here. Yeah, anyway, so any other thoughts here? Like what should be the next steps?
Yeah, my question is, what should be next steps? How do we proceed with that so that we can get it done before KubeCon, if that's possible? How do we vote for that, or do we just give community like few weeks to
I
decide?
think, yeah, let's definitely, so let me finish this to-dos, and then, you know, we can just propose, you know, add the Slack channel, follow up in the Slack channel and follow up with the community what should be our initial design. And then I think, you know, in maybe sometime in next week we can start with the implementation. At least like we don't need to have like all the implementation, but at least initial, you know, just optimize API or builder if we decide to use builder approach.
And then a quick question, do we want to refactor the API before migrating the SDK, or we can do that right after?
You're talking about experiment API.
Yeah.
So no, so CRD, so you can show.
Not CRD, the optimizer API.
Yeah, but we don't have optimizer yet at all.
Yeah, but we will migrate the code, or do we or we don't
Yeah, so the
migrate
old code
clients.
will actually, yeah, we need to write it from scratch because old code won't work with train jobs, old code won't work with the new API.
And what do we do with old code with like Ktype client?
Yeah, I think we probably will just need to maintain it for at least for some time.
So
For-
we will keep it within
Yeah,
Ktype.
yeah, yeah. We should probably keep it because
repo?
we have customers, yeah, probably using it. So
Or do we keep it in SDK repo then? Or
yeah,
just
SDK will be new, completely new clients with new APIs.
so we will have two clients
Yes, like
Okay.
Ktype SDK will live separately at least
and we
for
will deprecate it at some point.
yeah, maybe I mean sometime like but
Yeah.
not soon.
So
Like
we can go ahead and maybe migrate the SDK right now and then add the new client once we
yeah,
have.
so we don't need to migrate SDK, right? We can start to write a new client directly in the SDK repo.
Yeah. But what are the preferences? Like, do we just migrate and then add the new client in the new repo? Or do
Oh, so the thing is like we don't need to migrate all client because all client doesn't use train jobs at all. And the old clients, I think we should do some refactoring there
Okay.
while we
Makes
do
sense.
the migration. Not migration, but basically we need to write this from scratch
Yeah. Okay.
because the old API won't really work.
Yeah.
Yes, Ari, you have a question?
Yeah, really quickly, I think I do have a suggestion and maybe another question. A suggestion is like maybe we can send this document and create a vote. I don't know if you can create a vote on Slack or a vote on the mail list, like to the members, and we give it some time. We say like the vote will be open for like 1 or 2 days till the next community meeting, and by I don't know, next community meeting might be a little bit too late. Maybe we'll open it for 1 week and then, okay, you can vote on the name, you can vote on the decisions that we need to take, and then it's final. You voted or not, we give some period for people to do that. Another thing that I had in mind, are we going, since there might be some conflicts with SDKs and stuff moving, can we just cut a release maybe for Katib? I know there is no new code probably on the backend, but we cut a release with the SDK on the backend repo, and then when we migrate, and after we migrate, the new release, like similar we did was to the trainer, the new release after after we tag a release, the main branch will just like have no SDK.
We will still need to cut the new release because we publish the models to.
Yeah. So I think we probably should forget about Ktype SDK at all because that should exist for some time because it's different from like this SDK should exist. We should not really migrate. We shouldn't really touch it. And like we should basically write SDK from scratch and using the models that Anya is working on to publish them on Pipey. And yes, we can make a release for Ktype when these models had, when we're ready to publish them.
Okay.
Yeah. Does make sense?
Yeah, that does make sense.
Do you think it's
Cool.
feasible to do within
To
the
do a release?
No, the whole
So before
implementation for the
Oh,
next
yeah, I
1
mean,
month?
definitely. I mean, I think I mentioned this before. I think it's not really rocket science. I think like, it's like very simple to do some initial APIs. We don't need all the APIs. We can only have optimized API, or maybe get job API.
Okay.
I think it's definitely possible because the problem is, yeah, good.
It's just time consuming to make the decision on what API will proceed, etc.
Yes, but in any case, I mean, Ktype SDK doesn't have anything like you find useful as of today. So because Ktype SDK doesn't really work with train jobs and also doesn't have the integration with train job data classes. So all the things we design in the trainer SDK, it doesn't really work with Ktype SDK, which means in any case we need to write this from scratch. Yes,
a very, very, very quick item, a discussion for another day, not for today. I think there are some similarities between Trainer, Katib, and probably other projects too. I'm not so much familiar with them, but maybe we can make a Kubeflow SDK core part to something like a job kind of API that only gets a job, lists jobs and delete jobs. I know like list jobs might be a little bit different because it works with a CRD, but getting logs or deleting a job, it's all CRDs, right? It's all
yeah,
like
let's
operating
definitely
on
talk
CRD.
about it. So I think
Yeah.
I think there are some confusion because I kind of expect that list job will return different data classes. Like for example, we have data class for train jobs, we get data class probably for optimization job.
Yeah.
Which means like yes, I think there are some discussion in terms of having Uber client on top of all these clients, but we don't have a concept of Kubeflow job. What does it mean? And different jobs might have a different specifications. Like what is work for Spark job might not work for train jobs.
Yeah, makes sense. Cool.
Anyway, so yeah, great discussion, guys. Let's definitely follow up on this, and I will let you know like once I have these things in the doc, and we can definitely talk about next steps before KubeCon. So evaluate some initial implementation there.
Perfect.
Thanks everyone. Speak to you soon. Speak to you soon.
Thanks, guys. Bye-bye.
Yeah.